this part of the meeting. Great.
It's great to have you here. We need experts in this area, both you and Paul, and I hope
Elias and
Luis are here. I know they're already here.
No.
Okay.
Not
I
yet.
hope that they didn't have any problem coming in. We had some updating problems that people that didn't update Zoom had some problems today in the morning to come in, but hope that now everything is solved. Okay, but we have a lot of participants.
That's good.
Almost, I think, 90 people. So I hope we'll have a full session. It's a pity that I'm not able to see everyone, but well, the internet has some advantage, but of course, many disadvantages also.
Yeah, it's true.
Yeah.
Let's see. Okay.
Right now. Great.
You managed to assist to any of the sessions, or you weren't able to do it? You are not hearing me.
Yes, we are.
Okay.
I didn't
You
attend. I didn't attend because I have an examination tomorrow, physics, so for 150 students, and so we had to have
everything ready.
Yeah, ready.
Luís Conceição. Hello. Olá.
Olá.
Olá, boa tarde a todos.
Olá, boa tarde. Obrigada por
Boa
ter
tarde.
aceito e vindo aqui ao debate. Está
Olha essa.
quase a começar.
Obrigado pelo convite.
Elias is also coming. Okay, great. Hello, good afternoon, Elias. Thank you very much for being here.
Maria.
Thanks a lot for coming and joining us in this debate.
My pleasure.
Thanks. We have 3 minutes to start. It started at 4 here, 5 there. So we'll just have to wait. Although people are coming in, which is good.
Okay.
But let's
We'll wait.
Okay.
Ay. Buenas tardes, Elias.
Hola, Joan.
¿Qué tal?
Bien. Hello, Paula.
Hola, ¿qué tal?
Nunca nos habíamos visto, creo.
Sí, creo que no.
It had to be in Zoom.
Solo en papel.
Sí, verdad.
Agora cumprimentamos a todos e a Paula em particular, o Luís, que
Olá.
também já
Boa tarde.
Olá.
Hola,
Es verdad.
Luis Conceição.
É, obrigado.
Muito prazer.
Partilho também convosco que a sessão já está a decorrer no YouTube.
Okay, obrigada. Só a fazer 2 minutos para começar.
Tá bom.
Many people just went, the break was short, so I suppose that many people went for a coffee and they will come in. Anyway, we already have 27 people here.
How many people were registered in the symposium?
I think around 90 or 100. Francisca is better than me having those numbers correct, but for sure more than 90 people.
And are they mostly from the academic sector?
Yes, not just, but most of them are
Mostly.
from the academic sector.
Conceição, I just took some minutes to find the real numbers. So
Okay.
we've had already 110 visits to the platform. So a lot of people.
Okay. Very good. Mhm.
Very good.
Thank you. Okay. So I think we are on time. So I think we can begin. So hello, good afternoon to everyone. I would like to thank you all for coming, especially our persons that are our researchers and stakeholders that are coming and discussing with us and participating in this debate that I really appreciate. I will just introduce Luís Mira because he is the one that is going to present you and chairing this debate. So Luís, he's a professor at University of Lisbon and partner at Consular. He has been president of Inovisa, which is an organization, a hub for research and development of visa. He's also consultant of the World Bank and board of several organizations. So he will be the chair of these debate sessions. So I thank him also for this, and I will pass the word to him. Thank you, Luís.
Thank you, Conceição. I hope everybody can hear me. Yeah. Well, thank you for this invitation. It's a great pleasure. I know some of our speakers, others I know by name. We'll be talking about water management for sustainability. So we could have a whole symposium talking about this if you want to address this issue on a serious way, on a detailed way. When we mean sustainable water management, we mean using water on an environmental, social, and economic sound way. Using water now, without compromising the ability to meet the use of water in the future. And of course, we're talking about agriculture. So this is a big topic, and a big topic now. And I would say, very unfortunately, a very hot topic at this moment, because we are under already I think in Portugal for sure, in Spain I think for sure as well, under a difficult year in terms of water. We're facing drought at this moment. So we also more conjunctural. We all know that we're facing a period of increasing prices, and I would call it food shortages for sure, but fortunately not in Europe. But and we're facing lack of water. And so this is, I think, a good time to have this discussion here. And to have this discussion, we have a wonderful panel. I will not introduce each of you, because I will ask you. You have 10 minutes to do a first our panel. We asked everyone for 10 minutes to do an initial presentation, and then we want to have a good debate. So we have 10 minutes for the presentation, and each time I pass the word to another speaker. I will do a brief introduction before passing the word. The panel includes Elias Ferreiras, who is a professor at the University of Cordoba in Spain, we have Paula Paredes, who is also professor in the University of Lisbon in the School of Agriculture. We have Luis Alcino Conceição, who is a professor at Polytechnic Institute of Porto Alegre, so near Spain. And we have Juan Girona, who is from IRTA in Catalonia, but also he's also a professor. So I think we have like a pocket of professors here. And people, and of course, everybody's, all of us, including myself, I think, including myself, we are all connected to, have been working on water management and for many years. So I hope the debate is to be fruitful. So let's start with the initial presentations, and thank you for being here. Thank you for all the participants. In the debate, I think we'll have some time for questions. So if you want to, if you are watching the session and if you want to put some questions, I think you just have to go to the chat, put the questions, and I will try to moderate and to read the questions and try to, and we'll pass the questions to the to our speakers. I will not follow this order. In this case, I will do ladies first. I will start with Paula Paredes. And Paula Paredes, she's, as I said, a professor in the Agronomy Institute. She's also linked to our research center called LEAF, Landscape, Environment, Agriculture and Food. It's a research center linked to the School of Agriculture. She has, I think, now a strong career scientific career with more than 50 papers, international projects, national projects, and she's editor or a reviewer of several journals. So a sound scientific career, as far as I know, mostly related to water and water management. Paula, the title of her presentation is Challenges for Irrigated Agriculture in the Mediterranean region, and that's why I'm starting with you, because I want to start with the challenges. So I pass you the word, and thank you for being here and for the presentation.
So first of all, thank you very much to the organizing committee for this invitation and to be part of this roundtable that it's dealing with a very, very challenging thing that it's water management and sustainability. So I'm going to share my presentation. And as Luis was talking about, I will talk a little about the challenges that we have nowadays for the irrigated agriculture, basically here in the Mediterranean region. So the challenges are today, nowadays, worldwide, is that we have to increase food production. And it's foreseen that in 25 years, or more or less, we have to increase 70% the food production. And this increase has to be sustainable. So we have to have practices and technologies that allow us to achieve this increase in a sustainable way. So looking at production, what we see is that we have rain-fed agriculture and we have irrigated agriculture. And we can see that nowadays we have actual production that it doesn't reach potential production. And so we have a yield gap. And this yield gap mainly concerns not only the need of inputs like nutrients, fertilizers, and so on, but it also includes the lack of other things. There are several constraints, not only water. You have also weather. We have diseases and pests and weeds. So we have to decrease this yield gap, even if we have more high-yielding crops. So here we have rain-fed agriculture and irrigated agriculture. With irrigated agriculture, we will increase yield. So despite these new crop varieties that are emerging, we have to this challenge that is this yield gap and to reduce it. So we had a study, and we we were looking at the water productivity. Water productivity is nowadays a very common word. So we are looking at the yield per cubic meter of water that is applied. But when we are dealing with grain-fed crops, so this yield is much smaller than we have with irrigated agriculture. So under dry and very dry climatic conditions, we know that the water productivity is very low because we have very low yields in rain-fed conditions. When we look at the economic water productivity, so the value of the yield per value of the total costs that are applied in rain-fed agriculture, we'll see that under very dry climatic conditions, so severe droughts and extreme severe droughts, that the economic water productivity is below 1. So you will have not an income, a positive income to farmers. So in these conditions, we have to have irrigation. So now we are facing this reality. If we look at the early 90s, we have some varieties. This is the case for maize. So this old varieties of maize, they yield less. Nowadays, we have more production per hectare. So the yield increased. And this increase was not only due to the crop varieties, it was due to technology and to better irrigation schedulings. So this is an improvement. So we decreased the yield gap. Okay. So in terms of irrigation, we need to have water availability. And we see that in the Mediterranean area, we have water scarcity. And in the future, this water scarcity will increase a lot, particularly here in Iberia. It will be very high water stressed. So we have to face this. This is a big challenge for us. So we all days we are hearing the news, and we are seeing that there are more increased extreme climatic weather events, and farmers are saying, well, we have droughts, we have floods, high precipitation. So how can we deal with this? And we see that climate change are impacting even irrigated agriculture. And how are they going to impact? Change in timing and phenological events, so the crop development stages and growth, the yield, and then we have increase of weeds, but we also have increase of water use and water requirements. So irrigation requirements will increase also due to these climatic events. We have also high concentration of precipitation, so we'll have soil degradation and erosion. So these are a lot of impacts that we have to face. So instead of dealing with the risk, we can prepare for the risk and to manage this risk. So we know that droughts are pervasive and long term, so we have to mitigate. But instead of mitigate, why not we have preparedness measurement? We know that droughts are difficult to predict. So we have to have early warning. We can also have changes in water allocation and delivery operation of water systems. And we can use also alternative sources of water, like treated wastewater. But we have to have it with a good quality, otherwise it will impact the environment. But we can also reduce the demand of water, of course, and have water saving practices, particularly in terms of irrigation. So we have to develop public awareness, but the most important is to have good technical support to users. Of course, financial support, that it's also mandatory, of course, but we have also to talk about water pricing policies, of course. In this presentation, I will focus mostly on the early warning and the the practices to reduce demand and water savings. So in terms of early warning, we have done a study where we use long-time weather forecasts. Of course, they are not good, as we all know. Sometimes even short-term weather forecasts are not accurate. They have uncertainty, of course. And in this case, we studied mainly to see if farmers could use this kind of information, at least to have an idea on the amount of water they would have to use in terms of irrigation. So we see that reference evapotranspiration, that it tells us the climatic demand, and then precipitation. They are not completely accurate, but at least they have some guidance. They could have some guidance for farmers. Of course, we have also studied in terms of the impacts on grain yield, and we know that they have an underestimation tendency. And in terms of irrigation requirements, the forecasts tend to underestimate the irrigation requirements. As I told, weather forecasts, of course, they have uncertainty, but we have to have also, so we should have a risk assessment. But this could help farmers, and not only farmers, but also water users associations, in order that they at least could have in 7 months, 6 months for in advance some support in order to their decision, of course. But at least this can be a way to do it. So sustainability at farming mainly focus on sustainability of water use, and therefore solving the imbalances that we have between availability and demand of water. Of course, we have also the degradation of soil, of the surface water and groundwater quality. Again, I will focus more on water availability and demand. So the availability is focused on water supply, and water supply mainly focus on water storage and water reuse. So for water storage, what we can do, we are seeing that we are having more extreme precipitation events. So we have to have a more ability to storage water. So one of the things that we can propose is to increase the ability of the already existing dams to support more water, to store more water. Of course, that we all know that our irrigation schemes, most of the old ones, are using open canals, so we can improve the classical transport of water and increasing also the distribution efficiency. We have to promote the construction of dams, small dams, earth dams, in order that we can collect runoff, and also to prevent soil erosion and to have water for livestock, for instance. And we also have to decrease the water losses by evaporation in small reservoirs like those that farmers usually have. So these are things that we can implement in a short term. In terms of decrease of water demand, we can use crops that are low demand in terms of water, use crop patterns that allow us to decrease the water demand. We have also the help of plant breeders that can provide us new crop varieties that are more tolerant to water stress, adopt irrigation deficit. But this has to have always the support of technicians, and those technicians must have training and to know how to communicate with the end users. Then we have also the selection of sowing or planting dates. We had a study where we, again, with winter crops, in this case was barley, and we studied the use of deficit irrigation, or full irrigation, or even rain-fed. So we saw that under severe drought conditions, the total available water that was used, we could implement different sowing dates. So we know that less water is used when we anticipate a sowing date. But in terms of yield, we have to push that sowing date in order that we have more yield per unit of area. So the same pattern occurs when we have extreme drought conditions. But when we look again to the water productivity and economic water productivity, then we have face a different kind of solutions. So in both cases, we have that postponing the sowing date to the beginning of January, it will increase water productivity and then economic returns for the farmers. So this is another issue that we have to bear in mind. Okay, so if we look at in terms of water use, we have to anticipate because we have precipitation during the winter, but in terms of yield and economic return, we have to postpone, okay? So this is an interesting issue. So in terms of water savings, what we have to do to improve irrigation systems uniformity and management, and this is an example. This is the farmer, and as you can see, the irrigation system, it was not well managed. We have drippers that are clogged, that had clogging, and so there's no water, and there is other that it's completely damaged, and so lots of water, and then you have waterlogging in the field. So we have also to use water from spills and runoff, and then improve irrigation scheduling. So all of these are measures that we can use for water saving. For water conservation, there are a lot
Paula, 2 minutes, can you make it in 2 minutes?
Yes.
Thank you.
So in terms of water conservation, there are lots of techniques that are widely used, and they can be they have to be promoted, and their adoptions. So then adopting appropriate technologies. We know that modern sprinklers are very good and can have excellent performance, but they have to have good design and have good maintenance. So these are also issues. So maintenance and uniformity evaluations must be applied, otherwise we can have a very good technology without good performance, and then we don't have water savings. Same applies for drip irrigation, of course. So we have to have support to the farmers, not only just to sell the irrigation systems, but also to support them in their day-to-day basis. So we have now a project focusing on different levels, so from farm to basin, and the objective was to improve the sustainability of the irrigation systems. In the past 20 years, the average performance of this kind of systems much improved, but there is still again a gap. So we have to try to reduce the performance gap. So this project allows us to have a bottom-up interdisciplinary approach and making use of emerging low-cost technologies, using participatory approach and training. What we see, we have to have education, research, extension, and training, baseline to have improvement in water use and sustainability. So challenges. We have knowledge and technology already available, but we have to better disseminate to farmers. There is potential for increasing performance of irrigation systems. We need to have innovative solution on water resources use and management to face the climate changes and food security. And there is a strong need for a participatory water governance and policies. So thank you very much for your attention.
Thank you very much, Paula. I had many questions, but I will leave them to the end, and I hope other people will help me also to. But it was good to have like an introductory, broad presentation that help us to now to construct on the discussion. So I will now pass to Juan Girona. He's, as I said, from IRTA. in Spain, and IRTA is the Instituto de Recerca y Tecnología Agroalimentaria. So I think everybody understood, despite my accent. He was also General Director of Food Quality and Food Industry in the Generalitat de Catalunya. He was program director at IRTA on efficient use of water. So somehow the discussion we're having here. And he is also a professor at, he was, I think, professor at Universidad de Lleida. But the most important, he's been working on water management and water sustainability for many, many years. And he also has a very extensive research career in this subject. So Juan, thank you very much for being with us. The title of the presentation is Irrigation Management should be coupled to agronomic practices, in this case in orchards, but to improve water uses. So it's like there are a few projects discussing holistic approaches, and I think this is an holistic view of water management. And of course, I think this is the direction that we are all moving into. So thank you very much for being here. And if you can stick to 10 minutes, thank you. So thank you.
Okay, good afternoon to everybody, and many thanks to the organizers for inviting me to participate in this meeting. I will try to share my screen. Let me see if we are able to do that.
Yeah, it's okay. No.
No. What? Let me say what half of a screen. This one?
No, I saw it. Now it's okay. Yeah.
No.
No?
But it's not this one.
I know.
Let me. Oh my God. No, the problem is that
Don't worry.
It should be this one, but I don't see the presentation.
Now it's the presentation I see. I think it's
Yeah. It's the one that we want to see, but it's not like the. Okay.
Juan, maybe try to share your whole screen instead of just the PowerPoint window.
Yeah, it's exactly what I was trying to. Let me do one thing. One moment, please. And perhaps here I will solve once again the problem. I don't see. It was already prepared for this.
Are you using two screens?
Yeah, and now I just closed the screens and I don't know why. Sorry.
If you disconnect one screen and you just
yeah,
use
it's exactly what I did. And let me say if we are able finally to go to the presentation. One moment, please. I don't know why it's not moving.
But we can see it like this. We just.
Yeah. We will follow like this.
Go to the first slide because you are at the end.
Oh, perhaps.
Okay.
Okay. This was the problem. I'm sorry. I'm sorry. It was the end of the. Okay, I will go really fast because my idea is just to introduce a couple of ideas that I'm trying to summarize these ideas in the title. No, I mean we should connect more the irrigation management with the agronomical of the orchard practices or the agronomical orchard requirements. To do that, we have an old technology that it has been useful in the past to evaluate our orchard water requirements. As all of you know, this is the general equation to evaluate the evapotranspiration demand of an orchard, of a crop, which is the ETO times crop coefficient. And at the beginning, these crop coefficients were very with a little information, only in the initial phase about 480. I mean, I put the almonds because the background scenario is an almond orchard, and then in the mid-season 90, and at the end of the season 0.65, but with no any other information. As we move, different authors, they realize that this demand, it depends of the site of the tree, and they try to relate the water demand with the shaded area, which really improved the situation, or even adopting new ideas about this crop coefficient, separating which is what they call the dual crop coefficient, which is the part of the evaporation of the tree from the transpiration of the tree separated from the evaporation of the soil, which is really useful to apply these crop coefficients to different irrigation systems that they wet different areas of the soil. And also, another works, they try to relate the crop coefficient or to adapt a new coefficient to evaluate the water availability, and then the demand of the tree is also related to the soil water availability, and then try to relate in this sense. Further, other studies, they relate directly the crop coefficient, like you may see here, for instance, in apple, in this part of the graph, with the intercepted radiation and none. And you may see that if in apples you intercept about 40% of the radiation, you may have a crop coefficient about 0.6. And this is a new way to approach the values that are closer to what really the tree demands. We have these for apples and for pears, or another these ones for peaches, and then we have in other crops. It's only a summary. In summary, at the beginning, we knew that orchard water requirements, it depends, of course, of weather, on the crop that we have, on the tree size. It should be percentage of shedding or by light interceptions. It's also dependent on the irrigation systems, how much area of the soil we wet with our irrigation system, also how frequent we apply the water, of course, the soil water availability, and the cover crop, if we have cover crop or not. However, there are many other agronomical factors that they are really involved in the orchard water requirements. And if we want to be really efficient in the way that Professor Paredes explained it a few minutes ago, we also have to take into account all of these other conditions that can make change the demand of our orchards. Probably one of the most important is fruit load. And in this step, I will analyze a little bit several examples. The first one is this one in apple, that we can see that with very low fruit load, with high fruit load, the crop coefficients for a full canopy development, they are completely different. The trees with a heavy fruit load, they have much higher crop coefficients than the one that they have low fruit load. Also, in another type of experiments, we evaluated that the plant water status through the season, it changes, applying the same amount of water, and trees with more or less, exactly the same development, I mean the same canopy volume and the same percentage of shaded area or light interception, they have different plant water status. For instance, only to illustrate this figure, we have here the trees with a heavy thinning, I mean the trees that we remove at the beginning of the cycle of the season, we remove a part of the fruit, and the trees without thinning, I mean with a very high crop load. I mean, then fruit load affects not only the demand, but also the plant water status, or even the relationship between stomatal conductance and some physiological parameters. And
that stage list might have had more cons than pros.
Let me see. What happened here? Okay. I don't know. And then, okay. And then also,
Well,
I don't know. Somebody has the connected.
Francisca, can you check? Francisca?
Yeah. Okay. Let me go to the first part. I mean, even it changed the relationship between plant water status and transpiration. Also, from another work, this one it's in apples, that they realize that the size of the fruit, it depends, at the final size of the fruit in apples, it depends, or it's related to midday stem water potential. And we have these nice relationships, and we decrease the midday stem water potential, we increase a better water status, we increase the size of our apples. But this relationship changes dependent on the fruit load. And here have the fruits per tree. As we have less fruits per tree, this relationship is above the ones that they has higher number of fruit per tree. But additionally to the fruit load, there are and also related to the fruit load, and directly to the background picture that we have in this presentation, this almond orchard. In this almond orchard, we apply during the last year different irrigation strategies, or more than different irrigation strategies, different amounts of water to different treatments. And in the year 2019, we have this seasonal evolution of midday plant water status. And you may see the treatments that they receive more water, that is the blue line, the stem water potential, it's higher than the treatments that they receive less water, the red line, which is lower. And this was a really heavy fruit load, really heavy crop, what we obtained in all the treatments for this year. But the following year, we have a really low fruit load. And this is the same patterns. Definitely, the fruit load affects the plant water status and the demand. But unfortunately, what do not have to manage these situations, what we don't have is the relationship, which is how the crop coefficients is related the fruit load. This is something, this is only one example of things that we don't have, and they are necessary if you want to improve the efficiency or the productive efficiency of using water in our orchard. And other aspects among the fruit lot, it's the seasonal sensitivity to water stress, the sanitation, rootstock, summer pruning, or even the commercial orientation of the orchard. What quality is expected in this orchard, or what type of crop the producer expects from this orchard. In this sense, what we need is more agronomical knowledge, mainly research, but not only research, and then new technologies to apply this knowledge. Because if we increase the knowledge, then it's much more difficult and much more complicated for the growers to apply this knowledge to the field. And I will finish the presentation. What I said at the beginning, my idea was only to introduce this idea that one way to improve our water use efficiency and to be more efficient and more sustainable in the future is knowing this part of these topics that is at this moment is a lack of knowledge, and that they can improve our water use efficiency. That's all, and thanks for the presentation. I'm sorry about the problems with the slides.
Thank you very much, Juan. So more food for discussion in the debate. I will move on because we are getting a bit late, and I will move to Luís Alcino Conceição, who's a good friend of mine from the Instituto Politécnico of Porto Alegre. So as I said, it's near Spain. And he's also the coordinator of a new center that was created, I think, recently, 2 years ago maximum, which is a national center of competence for technology innovation in the agroforestry sector. It calls InnovTech Agro. He's also a researcher with the MED Research Center, which is linked to the University of Évora, and he's also working not so much as in the other cases, not so much linked to water management, but mostly to technology, which is, of course, a big topic in water management. So, Luís, thank you for being here. And the title of his presentation is Extensive Livestock in the Mediterranean Regions and the Importance, of course, of water management. Luís, the floor is yours.
Thank you very much, Luís, for the presentation, and thank you for the invitation once again to you to be with you this afternoon. Well, I bring you maybe a complementary approach. As we said, I'm not quite a specialist in irrigation. Maybe I'm being considered an extensionist, and I'm working for several years in mechanization, and since 2016 using no-till sustainable way of crop production, especially for fodder crops, to cattle. So I remember when you made me the invitation to bring together these two scenarios, one way the crops and the other way the livestock. And sharing my small presentation that I put it since yesterday. Well, why livestock? Because, just to put it on, here it is. So in two parts. The first one is something about the extensive livestock importance, and it's a picture took yesterday in our field in Elvas, near the border with Badajoz. This is extensive, this is sustainable in my point of view. in all kinds of the scenarios of animal welfare, environment, natural resources, and of course in the pillar of involvement of society and to have a proper activity. Wildlife stocks, because wildlife stocks, it represents nowadays in Portugal 38% of the total agricultural activity, if we speak in terms of livestock. And if we look these two charts, in Alentejo, it's quite an important activity, considering the percentage that we have of animals, especially the ruminants, bovines, sheep, and goats, as you can see the distribution in the south, in the region of Alentejo. I think this is quite similar in Spain, at least in the areas of Andalusia and Extremadura, and with a very similar conditions of conduction of this kind of animal effectives. But this extensive activity, if we were in some countries of the North or Central Europe, it would be interesting because speaking of extensive systems, it's put the animals, like you saw it in the small video I showed, all in the field, having the cheapest way of being fed. And if in these countries we have this kind of climate, it would be very okay in some way, because this, for instance, with the example of Amsterdam, we have a quite warm and temperate climate, and we have all the year, almost all the year, regime of rainfall. Unfortunately, in this scenario of Alentejo and also in some part of Spain, I suppose, we have a climate, Mediterranean climate that Paulo already told a little bit about it, in which we don't have almost any rain in summer or in a large period of summer, and is a very concentrated rain regime in the winter time. So more than the difference of the total rain regime, it's the concentration that we have in this kind of regions. And to make the conjunction of these two scenarios between climate and between the need of have good pastures for these animals in extensive, this is a classic cycle of pasture that we defined in these kind of regions, in which we have a good, let's say, in terms of yield and quality moment in springtime, let's say, depending on the year, but usually between March and June, I would say, and something depending on the climatology of the year in the beginning of October with the first rainy regimes, fall rain. But we have severe difficulties of quality and quite a large limitations in terms of quantity when we speak about summer and in winter, this time of the year, if we were in a typical winter. And to manage animals, this is a classical bovine breeding cycle in which we have to put animals with a supplementation, usually sometimes even in the end of the summer, that goes forward the autumn and then goes in dry years or less rain years, cross all the winter, so that we can put animals with a very or an interesting body condition, so they can continue to have milk to their calves, and also so that we can have interesting fertility regimes so they can have a good supplement. And for that good supplement, we have to produce fodder crops or forages. So the problem is that not only we are dealing with a Mediterranean climate, as I told you, usually resumed by hot and dry summers and wet and cold winters. But here you have three registers that we have from 2018, 2019, and the last year. And as you can see, this is from Elvas, from the agronomic station in Elvas. And as you can see, all these 3 years, and I can show you more, we have usually a tendency that goes for higher temperature, annual temperature than the climatic normal, and less quantity of total rainfall. So this tendency, and as you can see, a very heterogeneous distribution considering the same months of the year, give us some difficulty to manage, and we have to find some solution, let's say some engineering to deal with this problem. So if we want to have some fodder crops to supplement the animals in the lower periods they have, and in the higher periods they have need of intake. And this tendency in the small pictures we have in the bottom right of the slide, we see that the tendency is for getting worse, because in terms of the rainfall regime and the temperature, it's supposed to we have less rain and more temperature. Well, so after speaking about a little bit livestock, let's speak about a little bit about water management, what we are doing. In Elvas, we have two projects. First one was MaxSmart, and this one currently we are having ISOMAP project, not specially dedicated for irrigation, but in which we are using some of the technology we are, I will show in a very resumed way. I would say a precision and for sure a sustainable regime. In one way, there are no magic solutions. The previous colleagues of my presentation speak already of some of them. One of them is the need to understand the crop cycle. In our cases, we are speaking about mixed crops, mixed fodder crops with legumes and grasses sometimes, or only with grass crops, somehow similar to a cereal cycle. It depends on the number of cuts we will do it since the beginning up to the end. But usually we are speaking of more than the crop cycle, the need of use the water in the proper moment. We have to do it. And for this, the important of have a local water reserve. And in our case, it's what I quite a lot say to my students. We are not in a typical extensive system. We may say that we are in an improved extensive system, which I think it's very important, because when we have some water reserve, we can deal with it to include this kind of crops where water yield is a very interesting factor for what we can get at the final cycle of these crops. So in this case, we are very tempted, considering this Zardox cycle scale, between the final tillage stage and the stem elongation, and finally considering grain filling and flowering. It seems a relationship between these two moments with the nitrogen applications and the need to have water so that nitrogen gets effect of our crops. The second point, I think it's important considering this kind of rain-fed crops, is soil monitoring and soil improvement. And let me say, as I told you, I'm not a specialist in irrigation, but from my point of view and let's say some experience in the field, we are very worried with irrigation, but I think we must be very worried also with drainage and runoff. That's why I told you that since 2016, in a very difficult plot we have, it's this picture on the right, a 30 hectares parcel in Comenda, very stony, very low profile soil. We started to measure soil electric conductivity. It's a very fast assessment of the plot, and we cross it with some profile, to study what is under the surface of this soil, and we try to understand what could be the beneficiaries of avoiding situations like this that are very, very, very often current in our plots, in our farms, due to compaction of the soil.
Luis, we have
Yes?
to move faster because
Okay.
if you can finish in 2 minutes.
And we put it with, we started with no-till, as I told you. So in one way, the electrical conductivity was useful to identify differences in the parcel so that we can manage irrigation in a different way, so that we can position these kind of sensors URC in different areas and not where we want, but where they were needed to put it. And on the third suggestion, it's to cross information with these sensors and remote sensing, because in fact, with NDVI and NDWI, we can have very small differences very soon that we can identify when and where we can have the need for more water to answer the question and to avoid, let's say, a poor of quality or quantity. And it's not our case, but with this approach, of course, we can go forward to, for instance, a variable rate irrigation system that in more precisely situation, we can put it, the water where we need it. So, as you see, Luis, it's fast. 4 conclusions to final from this experience we are taking in these last years. In one way, also in extensive livestock, in this kind of rain-fed crops, it's very important, the water factor. We don't have no doubt for it. In the second conclusion, we can say that more than the total amount is the proper moment where we give the quantity of water. In a third conclusion, I would say that, of course, nowadays we have quite a lot of technology. This is a very important to me factor when we discuss about irrigation crops. We never had so many technology, so many sensors, so many remote sensing that we can control and we can know what is going on in the crops and how water is being used. And at last, but not the least, we can't forget that everything this is true if we have local reserves and if we have proper equipment working. Because this maybe is one of the discussions, the water reserves nowadays in Portugal, and the second is the proper working of equipment. As Paula also showed in the presentation, we unfortunately several times don't see the proper working. Thank you very much.
Thank you, Luis. Thank you. So we will also keep some questions for the end. We now have our last speaker, last but not least, and Professor Elias Ferreiras, I keep you to the end, because it's like in a music festival, we keep the best band to the end. So I'm not raising the expectations, but you have a really long experience on water management, sustainability. I think most of us, know who you are in your career, but you are a professor at the University of Cordoba, and you've been president of the Higher Council of Science and Research in Spain. Also, I think a founder or the first president of the CSIC, is how we call this, Sustainable
Royal Academy of Engineering. Sorry.
Yeah. But I think you've been linked to the foundation of the how do you call it, the Institute for Agricultura Sostenible, no?
Yes.
Yeah,
that one I did.
Yeah, and just to finish, you also have an international career linked to CGR, president of the European Society of Agronomy. I have to say this because it's really impressive what you did in the last few years. I heard from you when I finished my degree in Lisbon. I was in Cordoba, and I remember knowing about your work, and that was not 10, not 20, but 30 years ago. So it's an impressive career on this subject. Thank you for being here. It's a pleasure to have you here. The title of your presentation is Managing Irrigation Water Under Drought, which is, I think, the huge topic that we're facing at this very moment. So thank you for being with us, and I give you the floor. Thank you.
Thank you very much, Luis. I have the pleasure to talk to you. I've always been very close to Portugal and Portugal agricultural sciences. And it's not a coincidence that one of my last students of my career is a Portuguese citizen and graduate of there and here in Wageningen, who's finishing his thesis now. I take it that you can see my slide. For those of you that are
not yet. Sorry, not yet.
Can you see it?
No, we're still seeing you.
Just a minute. Compartir pantalla. Okay. The usual. Let's see. How about now?
Not
Can
yet.
you see it?
No.
Oof. Let me get out. I'll go back to here.
Now something is coming. Yeah, now we can see the presentation. Thank you.
You can see it in.
No, not yet, but we can see it well.
In the right way. So this Zoom.
I think next to the 50%. Oh.
Yeah, just a minute. I have to just.
Yeah, exactly.
Okay.
I think that's perfect. Thank you.
You can see it now.
Yeah, if you move it on, we can only see the title, but I think if you click on the...
It's animated.
Okay, thank you.
Sorry about that. I wanted to rush.
No problem.
In fact, for those of you that are thinking that you would like to leave, I announced that I only have 4 PowerPoints. So bear with me. I have a few ideas to transmit, and then we can go into the discussion. The first one is about moving from the scales at which you normally work, from the cell to the whole plant, to the regional scale. And the problems in our region, meaning the Iberian Peninsula, center and south, has been already discussed by Paula Paredes. Professor Paredes hinted on it. We have increasing water scarcity, we have periodic droughts. In many areas, we have unsustainable groundwater extraction. We have pollution of surface and groundwater, the continuous reduction in environmental flows, and the threat of climate change, which I have listed as possible increased frequency of extreme events like drought, and a possible shift in the seasonal precipitation, which is in both cases very serious threats. Now, how are we going to approach solving the water management problems? Well, when we are under water scarcity, which is not only the present situation, but the chronic problem of South Portugal and South Spain, I make the analogy of water scarcity to economic scarcity. And when a family is short of money, every penny counts. So the first thing you need to do is to count the pennies. You need to do an accounting of the water sources and sinks, and do an accounting as precise as possible. And we have tools and today that allows to quantify the usage of water by the different sectors and the different users. So the first thing is water accounting. So the other aspect, which was already mentioned by Professor Paredes, is that you want to know the value of every penny. To know the value of every penny, you use the concept of water productivity, which is the production per unit water consumed, and that can be measured as yield, which is a biophysical water productivity, or can be measured in economic terms, which is a way of valuing the water productivity, or in employment per unit water used, always per unit water consumed. And that has to be done, or is desirable to do it, from the field to the fork, from the production to the consumer, bearing in mind that a majority of the water consumed is in the field, but there are losses of water along the food chain, and in particular with the food waste that we have in our societies. If we have a estimated waste of 30% of the food that we consume, then we are wasting 30% of the water associated to that productivity. Yeah, so this is a framework that I would like to emphasize: water accounting and assessment of water productivity to evaluate the value of water in our society. Now, I want to go downscale to farm irrigation management. And in farm irrigation management, I want to remind those of you that work on water relations, and presumably you are focusing at the whole plant, the individual plant, and we will start going from the individual transpiration, but the individual transpiration has little value to the field manager. What you need to know is the transpiration of the irrigation unit, that is the unit that you irrigate at once, and also you need to know the evaporation from the soil. If you know those two, which of course the transpiration of the plants is depending on their plant size, particularly when you're talking about trees. So you have an uncertainty about the variability of plant sizes affecting the unit transpiration from your individual transpiration that you can measure very precisely. And then you will have the crop evapotranspiration as one of the inputs. But there is another factor associated with the storage of soil water, which is affected by the spatial variability of soil water properties, and that will determine how much water can be extracted, which is also uncertain and is also variable inside the irrigation unit, inside the field. If you know also that soil water storage component and its variability, then you can come up with an estimate of what is the net irrigation input, the so-called net irrigation requirements, which are affected by the uniformity of distribution in the field. Some areas get more than others, even in the most accurate irrigation system. So you have an additional uncertainty there. It was already mentioned by Professor Paredes at the beginning. And then you also have another factor to consider, which is the gross irrigation requirements, and because there are uncertainties as to how much water is being contained in the root zone, so you have an inefficiency factor that you have to put in. So with all those uncertainties related to the variation in plant size, the spatial variability of the soil, the differences in uniformity across the field, and the safety factor that you put as inefficiency, to know the gross irrigation requirements, which sometimes is claimed, which is the goal of our research, there is a safety margin that is no less than 10–15% of their actual number. So to know very precisely the transpiration of an individual plant doesn't help us manage the farm. So this is just a reminder to focus your research on objectives other than improving farm irrigation management by doing very precise measurements on a few plants in the field. I mentioned I was going to talk about drought, and this is my last slide. We are in a drought period. I arrived in Cordoba in the 1980s. There was a drought period at that time. There was another period in the 90s. I had left California with the biggest drought of 1976–77, and they've had periodic droughts. Our climates are prone to have periodic droughts. One of the approaches that has been taken since the 1970s is breeding for drought resistance. That breeding for drought resistant efforts started in the 70s after 50 or 60 years. Not much has been achieved, only modest progress has been achieved in conventional breeding, but there is a promise of biotechnology which has been going on for 20 years without success, but is approaching better results. I think in the next 10 or 15 years, we will see some help in that regard. But the prospects in short term are not very positive. You can't find varieties that are particularly tolerant to stress more than others. And you have very few options in terms of selecting cultivars. Now, in agronomy, you have many other options, and some of them are quite viable. The most impacting one is to not plant. If you don't have water, you just don't plant. And in our systems, you have subsidies and whatnot to carry some of the weight. But of course, this is a very drastic measure and can only be taken as an extreme case. The next measure that has an impact on adapting to the drought is to change the crops and focus on crops that have very low water use. If you have decided on a crop, you can still use a short season cultivar to use less water. And another measure, agronomic measure that works well in our system is to plant early as possible. And this has been facilitated by the changes in climate that we've seen in the recent decade or two, when you have a warmer winter that allows you to plant early. You just need to think that the early plantings of maize now in the late February in Andalusia, and they used to be like late April or early May 40 years ago. So farmers have been adapting to these things. Now, when I say do not plant, I'm referring to annual crops, because the question of tree crops is much more difficult. You cannot you cannot pull the trees out, so you have to sustain the plantation, and that requires the use of deficit irrigation that was already mentioned by Joan Girona and Paula Paredes. Now, there are other disciplines that are very important. Also, I won't go into that, so that we have time for discussion related to supply and demand that are managed by the hydrology of our basins. And the important thing to finalize that I want you to think is to focus outside the standard box. What they say now, think outside the box. Well, there are many options that society has to deal with droughts. They are outside the scope of this meeting, but I think it's important as citizens to know them. As examples, you have water markets. Farmers, for instance, those that have trees can buy water from those that can afford not to plant and use it to sustain their plantations. They can buy from districts that have more water supply. Always if they have means of transporting that water from farm to farm. Then you have the possibility of reusing wastewater from the cities. Desalination is an attractive option because the requirements for energy are decreasing with improved technology. And as previous speakers have mentioned and emphasized rightly, we need to deal with our challenges, especially with the uncertainties in the climatic trends, and we need additional storage. We need both increased surface and groundwater storage, like you would store more money in the bank if you're facing an uncertain future. And with that, I would leave it there and leave some time for a roundtable, so that this roundtable is not like the common roundtable in the Iberian Peninsula where the speakers talk so long that there is no time for discussion. Thank you.
Thank you, Professor. We don't have much time, but Conceição told me that we could extend a little bit the program. And you mentioned 2 or 3 topics that I would really like to discuss further. But unfortunately, we don't have much time. But I want to ask you, let's start with the value chain. So first, with the supply of water, the storage and supply is exactly as you end your presentation. I think to me, it seems obvious. And Paula said that, Luis said that, and you said that we need additional storage. And fortunately, you separated groundwater from surface water. But you hear a lot of criticism on increasing the storage as well from environmental apologists. So are we storing too much water, or is this a concept of storing too much water, or shall we store as much water as we can? And please separate the underground from surface, because I think it's 2 completely different subjects. But what do you think about it then?
Very briefly, this is a very critical issue. The time I think at least in our societies, I will focus on our societies, the times for large waterworks, large facilities for storage, I think are gone because first of all, the best places have already been taken, and we need investments, increasing investments to do large storage facilities. And I think what we need to do is to find opportunities using the old phrase, small is beautiful. Find on farm, in a district, find at the lower scale facilities for two things. One is to store surface water at the smaller scales, which will give the farmers more flexibility, especially in times of drought like we're facing. And also to study better the groundwater situation and recharge. Some of those facilities use them to recharge the groundwater so that you can store more groundwater for the years in which the drought doesn't allow you to have surface water. So combine better and optimize the use of groundwater and surface water.
Okay, that's very, very, very interesting. Now, one question: when it comes specifically to groundwater, well, my view, which is maybe too simple, will be that we should have as many possibilities as we can of having boreholes to explore the water, but then we should monitor what is happening. And if we monitor, we are safe. But in my view, there is no reason not to explore it more if we monitor it. Is that the case?
You are correct. And I will not speak about the situation in Portugal because I don't know it, but in Spain, we have a big deficit in the water authority of controlling and monitoring the groundwater usage. It's kind of chaotic. Groundwater doesn't have the control that surface water use has. And the groundwater authorities are not enforcing many times the laws here in Spain. I don't want to say anything about Portugal because I really don't know. But here in Spain, we need a lot more policing, not policy, policing. The police has to be out there.
Monitoring. Yeah. No, I agree, because I think if we have more monitoring and controlling, we can explore more when there is water and explore less when there is less water. So let me just pass to Juan, because Juan said you talk about this holistic view of linking the management of crops with the management of water. And there is also I think an interesting debate that is going on, at least here in Portugal. And I will give a specific example with advocatos. Advocatos now, sometimes if you read the newspaper or some newspapers, it seems that it's a plant that came from hell in terms of water, because for some reason there are many people questioning advocatos because they use too much water. My question is, are there, in terms of water management, and I come back to Professor Elias Ferreiras, because you mentioned water productivity in terms of euros and not only in terms of kilos, which is very important. Are there good crops and bad crops, or shall we stick to water productivity and try to understand if take the maximum of the water we have? We cannot hear you. You have to unmute.
Yeah. I was muted. Of course, there is also the same questions. I mean, at the end, it depends of the value of the crop. And today, the value of one crop could be very high, and tomorrow would be very low. Then the economical value, it depends on times, and then we have the opportunity, as Professor Elias say, to change the crop, if the value of the crop in all the sense. No, we have to take into account different types of values, and he mentioned all of them. The economical one, how much is the return on euros for each drop for each cubic meter of water that we use, and also which is the social return, how many labor, producers, and so on. And also, in terms of nutrition, which is the part of nutrition that is given. In each case, we will need to analyze these different approaches, or even in specific times, this is the cost of energy. This type of management, irrigation or orchard or water requirements, what are the energy costs associated with this? I mean, this is something that it should be not constant, which should be flexible and adapting to the conditions of one specific time. At this time that the cost of energy is very high, probably it's useful to take into account the energy cost in this approach. But in the future, perhaps the energy will be not so expensive, and then will be an index less approachable. At this moment, because the avocado has a high price, then the economical return of the avocado is really important. In general terms, all the crops also, or the productivity of these crops is associated in how much water they use. In general, the crop water functions are always explains always the same. If you want a high productivity, you need to transpire a lot of water. As much water to transpire, you have higher yield. This is in general terms. Then you can change the crop and see other aspects. But for one specific crop, this is in general. If you want a really high or heavy crop, you need a lot of water. And probably the tendency that right now we have in our intensive agriculture is that we are looking for the highest crop we are able to get from one orchard. And this implies, in general, the maximum water and a lot of water. One of the things is that you decrease a little bit the applied water. Many times you realize that the decrease in yield is not so much. Then here we have a gap where we can play and find not the maximum water, sino the maximum efficiency of the water that we use. But in this case, we have to adapt. But something that is interesting, that this is not a fixed picture. This is should be variable in function of the conditions on what it happens through the time, no? And the value of the crops is one of these. If today the avocado price is very high, then
of course, yeah, and then the productivity per euro is much bigger. I was thinking when I was asking the question, I was thinking on when I asked good and bad crops, I was focusing on bad crops because of, in this particular case, the avocado. But I was coming back to, in my mind, to what Professor Elias Ferreiras said about annual crops versus permanent crops. And maybe there are good crops in the sense that a good crop, a good perennial crop, because I always remember what happened in California a few years ago, in which the trees actually were dead in the end of 2 years because there was no water to irrigate them. So maybe a good crop is a crop that survives without water, like an olive orchard. If you don't irrigate, or if you irrigate very, very little, it still survives with some productivity. So we might even have crops, perennial crops, that are more adapted to our
yeah. Of course, there are perennial crops that they are much more adapted. Olive and almond are the typical examples of rain-fed conditions that usually in our conditions we were growing these crops in rain-fed conditions, and now we are irrigating. But sometimes when you cut off the irrigation in one of these orchards that in the last period it has been managed under irrigation or heavy irrigation, then the consequences are very, very important, especially if you don't remove the fruit from the trees. One of the most efficient ways to kill an almond tree is to leave all the fruit in a really dry situation. Then it's for sure, because the tendency of the tree is to obtain enough carbohydrate for the fruit, and then it's transpiring until he's completely dead. I mean, there are some crops more adapted, but also the way that we manage previously to this situation, the crop, it's important.
It goes back to the holistic approach of, when I was hearing your presentations, one thing that also came to my mind was that we seem to have all the solutions there, but we also had like a study that was undertaken last year by the Gulbenkian Foundation in Portugal, saying that you also mentioned measuring the water you use, saying one of the data, one of the information was that only 30% of the farmers actually measure the water they use. That was in Portugal. So it's not only measuring water, it's the technology they use. And the perception I have is that we still have huge diversities in technology adoption by farmers. So it's not so much a question of if the technology is available, if farmers use it or not. So I will go back to Luis now, because I know you have you've been coordinating the center, this competence center dedicated to technology. So are we lacking knowledge, or are we lacking the use of that knowledge by farmers? And if we are lacking the use of knowledge by farmers, what can we do more than we are already doing to help or to foster the adoption of technology by farmers?
Well, Luis, I think it's we are living with all the technological solutions and new paradigm somehow. So in fact, there are farmers, I would say they are autodidacts in using, and they are very motivated to use it. But unfortunately, we all know, and you are saying also what I usually to see in practice, that there are many people that still, let's say, they don't believe very much in the information they can get, and most important, in the decision they can take with that information. So what we are trying to do with you also, and we all the partners we have in the center also in this area, is to disseminate, for instance, to being here, to being in other forums, to transfer technology with projects, to create more and more open days, field days, because I think this is a very antique problem in Portugal that is named rural extension, or nowadays the transfer technology. But nowadays, I think
advisory.
Sorry?
Advisory. We
advisory, yes, certain advisory, yes. That is now, as you know, very improvement now nowadays, but it wasn't in the past. So I think this is the way. Paul also said it. It's training. Put it in practice. Bring the university to the field, and more and more diminish. Because as I said, I know people that is very motivated and use the technology. And as I told you, I think we never had so many technology affordable to the farmer. For instance, we are very we have three types. We have soil moisture sensors, we have remote sensing, and as I told in my presentation, the electrical soil conductivity. I think these are three instruments quite interesting in all one. We can have quite a lot of information at the distance, but of course it will take some time to put everyone at the same capacity of understanding the information and the decision they can have. And what I think it's more poor, it's just to find the technology and to buy the technology to put it in the farm, and that's there. It's very nice. We have a sensor, but what do you do with the sensor? Oh, that's the sensor. That's
the feeling I have sometimes, and I've just asked the other speakers, Paula, I was going to say exactly that. If you have something to say, please raise your hand. And,
maybe it's better that we can all
of course,
intervene, because otherwise I'm just hearing and not speaking. So So my point of view is that we have information, we have the technology, but farmers don't know how to use the information. That's the main issue. You have the sensors and what to do with the information. They don't know how can they use that information in the decision making on the daily basis. They have the sensor, okay, so what does this mean? Should I irrigate? Should I not irrigate? What can I do? I think that's the main issue here.
But what is that's the issue? But my
that's the issue, and then
what's the solution?
What we have to do, train and the training is essential, because we have the knowledge. So we have to pass the information then to let them know, okay, if you see this goes below this threshold, so you have to irrigate, and then you have to use this information and use again weather forecasts also, and to see, okay, in the next 3 days it's not going to rain, or there is a low probability of raining. So okay, so I'm going to irrigate because it's almost in the threshold. So this kind of information is not that difficult to pass by, but if they don't just have the information, and probably having the apps, the applications on the mobile, just having an alert saying, okay, this is time for you to irrigate, or check this with the weather forecasts. It's not that difficult, and it's being made in African countries, so probably here it will be also possible to do and to save some water. I had some other, just give me 2 minutes, okay?
No, I prefer to go around and then you can, but okay.
No, but it was a question that you were talking about groundwater. And here in Portugal, we have a good monitoring of groundwater, not only quantity, but also in quality terms. But usually, we don't have the information in a day-to-day basis, okay? But we have that kind of information, and they could be used. There is other information that it's not available, that it's the private wells. The private wells that are where farmers are extracting water from groundwater, that we don't have that kind of information. We only have the wells that are from the government, and those are being monitored. But
the private wells,
the private ones are the ones that take most of the water from the groundwater.
Let me disagree with you in two, because we are mixing. I will start to the last one. On the private wells, and also Professor Elias Ferreiras said that I think it was you that said that in Spain the situation is not also sometimes not well monitored, and we also had a question in the chat about robust statistics, which is a step even further. But if you have a private well, you are obliged to monitor the water and the water quality. So supposedly, I think it was one that said, supposedly you are supposed to monitor the level of the water, and you are supposedly also obliged to measure the quality of the water, or to do some water analysis from time to time. So the question is if the services have the capacity to follow this situation in the field, which sometimes they don't, because it's too much big job to do. But you are supposed to do that. Professor.
Yes, I know of a successful management of groundwater, and this happens when the actual farmers are in charge. When you create an irrigation community, that they will share their resources. And I know in central Spain, in La Mancha, each well has a water meter, and there are inspections by the farmers, the farmers community. They go around every well making sure nobody takes more than what they are supposed to. and it works because you're sharing a common resource.
Yeah.
But it's organized by the farmers themselves, and maybe this is a future way of managing it. Thank you.
Thank you. So going back to the other point that also that Paulo raised, and that I'd like to hear from you as well, because I don't necessarily agree, because I think it's it's more complex than what you said. What I feel from the ground and from working with farmers and being a farmer myself is that if you are a farmer that specializes on corn or maize, yeah, and you have 1,000 hectares of maize, yeah, you can have everything, and you can training will work, and you can have the systems. But most farmers are mixed farmers. They have like 7, 8, 9 different activities, and they simply don't have time to cope with the technological advances and the knowledge that is available in all the crops. So either you have a good advisory system working on that helps farmers and tells them what to do. And I'm not being paternalistic because I'm a farmer myself. And as a farmer, what I say is, please don't tell me if I have someone, for example, I have pine trees, yeah, and I cannot dedicate more than 1 day per month to the pine trees because it's a lot of other activities, and I don't have time to measure everything and to and some farmers don't have even the scale to dedicate to enough time for each specific crop. So I think it's more than that, but I would like to hear from you. So
yeah, I had always the same feeling like you, especially because irrigation to me is one of the orchards practices or the more difficult or the more difficult by itself. I mean, pruning, you have to decide once a year what type of pruning you do, and that's all. With irrigation, you have to decide every day, every time, how much to irrigate here, then, and take into account a lot of information. Because of this complexity, many times the farmers, what they do is just to follow, to work as always they did, and don't pay attention to this because it's too much work. And in this sense, I agree what about you say. We need something easier to manage the idea. In this sense, at least in our institute, institution, but I know that other teams, they are doing more or less the same job. We are developing a tool, a technology that tries to integrate all the information and take the decisions. You are managing a little bit or directing, no? Okay, I want to be precise on this. I want my objective are these. My limitation are these ones. I mean, I can use only 60% of the total requirements and how I will distribute a little bit. But then you leave to the system, and this is a system that connects with the cloud in general, with the information, then process all the information there and give the orders to the irrigation scheduler. And you don't have to take the decision every day. You have to take the supervision of the system. And I think this is the future. This one of other ones that they are developing, I think will help a lot to introduce all of this knowledge and this technology for the farmers. Because as you said, is one farmer has to assimilate all the information, all the knowledge, all the variability that Professor Ferreiras highlighted, then it's not complicated. It's almost impossible. And because it's impossible, then growers say, okay, I don't go for impossible things. Let me pay attention to the possible ones. No? And I think we need this kind of technology that helps to introduce all of this information in our daily irrigation management.
Paula, do you want to add something, Luis?
Yeah, I agree with Juan. And I know about that kind of system. So they integrate with machine learning, right? So it's easier. But how is it communicated to the farmers? You have a platform, right?
Yeah. You have a platform, and then you have to have a good coverage about.
So they issue
mobile or any connection system. So that's another part of the.
So you have the information because you have the technology, and then how the information reach the farmer in this case is the main issue. In this case, it's a platform that issues an alert saying, okay, you have to irrigate, right? So as I told, the information, this kind of information that comes from different sensors, from machine learning, ground and remote sensing, this kind of information has to be collected and to be worked by researchers or by other or universities. It could be farmers and advisors, and small and medium enterprises. And then how to reach the farmer, it's just the information that is usable for them. They don't want to know if today the NDVI is X and tomorrow is XX, double X. They don't care.
No,
right?
no.
So they just want simple information.
They want to know how
simple information
and
how and when to irrigate. That's yes.
And how to make more money. Professor Elias, Professor Elias Ferreiras. I was talking about money because sometimes, again, we work a lot with farmers, especially in European projects, and sometimes we are studying behavior, and we forget that sometimes the first driver for decision is money, because farmer is a company, is a business, and they have to make money in the end. So my question is, and I had that question from the question and answers in the chat. Is water too cheap? Because I'm sure you had that discussion several times in your. Is water too cheap for agriculture at this moment?
Well, I once wrote an article that was called "Water has so much value that it doesn't have a price," and this is particularly important in situations of drought like the one we have now. I think it's very difficult to put a price. There are views, political views, which are common in some rural areas of both countries, that think that the land is privatized and everybody has his land, but water is a common resource that should be used to achieve a more equitable society. When you talk about that, then you're dealing with foundations of our economic system and society. So putting a price in water is a very touchy issue. What you know is more or less the maximum price that farmers are paying for it when they are in a limiting situation. And for instance, in the California drought, farmers pay more than $1 per cubic meter to save their trees. They were willing to pay a lot more than what they normally would pay, which would be maybe 5 cents or 10 cents. So no, it's a very difficult issue that cannot be resolved. And I think we have seen incremental improvements in all our farming systems in the way farmers are managing irrigation. And with the improvements in technology, farmers are learning, but we have to realize that they have many different activities, many pressing needs. You already mentioned it. They will not invest 1 second more than necessary to deal with one of the management inputs. And water, when it is available, is just an input, and it's normally very inexpensive in agriculture.
Luis, do you mind I put a question now?
Yeah, please go ahead.
I'm a forester, so a bit far from the agronomy side, but I just want to refer back to the bad crops and good crops, and also to what Professor Elias Ferreiras said about the agronomy adaptations, namely the change to other crops or to faster life cycle crops. And does this mean that in the short, medium term, farmers will go to they will leave the tree crops, they will abandon tree crops because you won't have the ability to decide on them so quick as perhaps you'll need in the near future?
I will separate two tendencies. One is the intensification of our traditional tree ecosystems, productive ecosystems, like cork oak or the olive. Those, I think, can be intensified, and it will lead to more productive use of the rainfall. Once you intensify its productivity with better agronomy. Now, we are seeing in both Spain and Portugal the introduction of intensive irrigated plantations of almonds, pistachios, walnuts. That is a different problem because in some situations, the water requirements of those plantations are very high. And in some regions of the south of Spain and Portugal, they may not be sustainable in the sense that in drought conditions, there won't be enough to supply them with 10,000 cubic meters per hectare or 8,000 cubic meters per hectare, which is our need. So on one hand, we can improve the productivity of our traditional systems and will make them more sustainable because they will be more productive. But one has to be very careful as to how much we can expand the new plantations in southern Spain and southern Portugal. You have a better situation in water supply with Alqueva, but there's always a limit. The farmers will push the limit.
Exactly. Everybody will push the limit. So there are much more topics that I think we should it's a pity we cannot discuss, like the soil health the issue, and that and the relationship between soils, the quality of the soils, and what we can do for the soils in terms of irrigation. Paula, we have to move to the end, but please go ahead. I'll give like 1 minute to each, and then we'll have to close.
Okay, just going back to the water pricing, we are always forgetting that the externalities of agriculture when there is irrigated. We never talk about the agricultural services. They are never paid, right? So I don't think that the water price is low. It could represent almost 30% of the total costs of a farming system. So I don't think it's that low. And we have to introduce also the cost of energy, particularly when we are pumping water, of course, for the pressurized systems. So I don't think it's a low price for water. Of course, if we put everything, yes, in a perspective, and we don't hear our politicians talk about the water in urban areas. They don't talk about, for instance, the irrigation of gardens, of those little gardens in between the roads. Do they? And do you?
I prefer to talk about rural abandonment and
no, but you. Yeah,
but it's not.
Yeah, but you have lots of water that is being wasted.
No,
it's
in percentual the terms is not that.
Yeah, yeah, but
the question
it's
of water
it's the pennies, as Elias was talking about. If we are going to talk about water savings, we have to talk about urban water also. And there, even in the pipes in the cities, we know that most of them have leakage, so that's a water loss also. So about water pricing, and I suppose that was all. Okay. I know. Just that. What's the other question about?
Very fast.
The implementation of new crops, particularly the avocado ones, and it's being a big issue. So I think that we have to have more studies about agroecological zoning in Portugal and in Spain, probably, where you have decision makers to look and to see if certainly, and users, of course, other stakeholders need to have that kind of information to know if a certain crop, orchard, whatever, is appropriate to a certain location.
Yeah, and just adding to what Professor Elias Ferreiras said, sometimes we talk about crops, but it's not only crops, it's also the genetic material and the varieties, because we are using different varieties for irrigation, and sometimes they are not so well adapted. Well, they are well adapted to irrigate for irrigation, but not necessarily. They are not necessarily the traditional varieties that were used under rain-fed conditions. So I think we have to close. It's late in Portugal, later in Spain. I think it was a really nice time. I have to thank you all. So thank you, Paula, Luis, Juan, and Professor Luis Ferreiras. I think it was a very, very interesting debate. And I pass it to Conceição from my side. Thank you for inviting me, and thank you for the discussion, and good success for the symposium. Thank you.
Thank you very much.
Bye-bye.
I just want to thank a lot all the panels for being here for this very interesting discussion. Next time, Professor Elias we'll begin by the discussion, and we'll have the presentations at the end. I think you are right, but it was very good inputs from all of you, so thanks a lot.
It's been in the best tradition of the Iberian Peninsula.
Thank you.
Bye-bye.
Bye-bye, thank you.
Bye.
And so to the rest, we'll go on tomorrow morning at 9. We'll start again, and we'll go on with our program of the symposium. And thanks very much. Thank you, Luis, also.
See you soon.
Okay, bye-bye.
Bye.
Thank you. Bye.
Bye-bye. And the webinar also